What you are looking at right now is the complete environment for our botnet demonstration. 4 virtual machines, 4 different roles, and individually, none of them looks particularly dangerous. But once they begin communicating with each other, they create something completely different. A complete simulated botnet ecosystem. Before I execute anything, I want you to understand exactly what is happening inside this particular lab. Because if you understand these 4 machines, you'll understand the fundamental architecture behind many real-world botnet operations. One important point before we begin. Everything you are about to see is running inside my isolated cybersecurity lab. These machines are part of a controlled simulation. The network is designed specifically for education, research, and defensive understanding. The objective is not simply to watch a botnet work. The objective is to understand the entire attack chain so that later we can ask the more important question. Where could a defender have stopped it? We begin here. So this is the first machine in our environment, the Kali Linux system. In our simulation, this machine represents the attacker infrastructure and the command and control server. Its host name is Kali. Its IP address is 192.168.1.250. Think of this machine as the brain of the simulated operation. But there is an important misconception I want to correct. A command and control server does not need to constantly attack infected computers. Once a device becomes a bot, the communication model can work differently. The infected machine can initiate communication back towards the command and control infrastructure. It effectively says, I'm online. Do you have any instructions for me? The command and control infrastructure can then manage connected bots, issue simulated instructions, and receive laboratory test data. So remember this machine. This is the brain. But a brain is useless until it has a way to reach a victim. And that brings us to machine number 2. This Ubuntu server represents the delivery infrastructure. Its host name is web server. Its IP address is 192.168.1.111. In this simulation, it hosts a fake software update website. To the victim, this may appear to be an ordinary website, perhaps a software update, perhaps a security tool, perhaps a utility that the user believes they need. And this is where technology meets psychology. The attacker does not always need to break through a firewall. Sometimes the attacker simply needs the user to trust the wrong thing. So in this lab, this machine represents that delivery stage. Its role is simple. Host the simulated update website, deliver the laboratory payload, and create the bridge between the attacker infrastructure and the target. But here, there is a problem. How does the victim find the attacker's infrastructure? For that, we need a machine number 3. This is our internal DNS server. Its host name is DNS, and its IP address is 192.168.1.106. And in this demonstration, it performs one of the most important roles in the entire architecture: name resolution. Humans remember names. Computers communicate using IP addresses. DNS connects those two worlds. So in our simulated environment, when the bot attempts to reach its laboratory command and control domain, this DNS server resolves that name to the internal C2 address. That detail is extremely important because defenders should not look only at malicious files. They should also look at infrastructure. They should also look at DNS requests, unexpected domains, unusual connection patterns, and systems repeatedly trying to locate the same destination. Sometimes the first visible sign of compromise is not the malware itself. It is the network asking a suspicious question. And finally, we come to the most important machine in the demonstration, the victim. This is a Windows client. Its host name is bot client. Its IP address is 192.168.1.108. At the beginning of our demonstration, this is simply a normal Windows computer. No dramatic warnings, no skull on the screen, no message saying you have joined a botnet. And this is exactly the point. Real compromise is often quiet. The user may continue browsing, opening files, checking email, and doing his normal work. Meanwhile, something else may be happening in the background. Once our controlled simulation begins, we will observe how this ordinary machine moves through the attack chain. From a normal endpoint to a system that communicates with the simulated command and control infrastructure. So now look at the complete picture. The Kali machine represents the command and control infrastructure. The Ubuntu web server represents the delivery mechanism. The internal DNS server provides name resolution, and the Windows machine represents the potential victim. 4 machines, 1 network, and 1 chain of events. The victim encounters the simulated update website. The laboratory payload is introduced. The system attempts to locate its destination. DNS resolves the simulated command and control domain. And the compromised laboratory client begins communicating with the C2 infrastructure. That is the architecture. But architecture diagrams are easy. The real question is, will it actually work? So before starting the simulation, I'm going to verify the network environment. This is an important habit in any cybersecurity lab. Never begin by assuming. Verify. I want to confirm 4 things. First, are all 4 systems running? Second, are they connected to the correct isolated network? 3, can the required laboratory system communicate? And fourth, is the Windows machine currently in its expected starting state? This gives us a clean baseline, because once the demonstration begins, we need to know exactly what changed. Right now, this Windows machine is our baseline. So remember this moment, because in the next few minutes, we are going to follow the complete simulated chain. We'll observe the delivery stage. We'll watch the DNS resolution. We'll examine the network communication. And finally, we will see whether the command and control infrastructure recognizes the new bot. So the 4 machines are ready. The network is ready. The victim is waiting. So let the demonstration begin.